Okay, our new unit is on radicals, which a radical is just a square root. So let's just do a couple of intro things before we look at simplifying these things. So the first part is if you have a square root of a number, like square root of 4, you do that on your calculator will give you 2. And the reason for that is a square root and squaring sort of are opposites of each other. So 4 is actually the same thing as 2 squared. So if we do the square root of 2 squared, you can see the square root and the square just sort of cancels each other out. So then we just get 2 for our final answer. Okay, one thing you got to be careful of is technically the square root of 4 could be 2, but it also could be negative 2. So if you do negative 2 squared, that also gives you 4, right? Negative 2 times negative 2 is positive 4. So that means we actually get a positive and a negative version for each square root answer, but in most cases we only worry about the positive one because we call that one the principal square root, or sort of the main square root. Okay, so just be aware that negative could happen, but most cases we're going to ignore it and just worry about the positive one. Okay, so because we have a square root, let's go back to this. So if I give you a square root of 4, because we're squaring it, there's actually a little index number of a 2 there to tell us that we're undoing the squaring. But because the square root is the most common, we don't always write that. We just leave it as a blank root, and that indicates that it is a square root. But we could do cube roots. So if we do cube root of 8, basically what that means is then we want to figure out what times what times what 3 times would give you 8. So 2 times 2 is 4, times 2 again would be 8. So now when you do the cube root of a number, you got to figure out what it's going to be times itself 3 times. So in this case, cube root of 8 is going to be 2. So the cube root undoes the cubed, just like a square root undoes a squaring. Okay? So a couple of different definitions. So in this case, we call that number in front the index. So that's the index of the roots, whether it's a square root, cube root, fourth root, fifth root, you could do a whole bunch of them. And on your calculator, if you need to do a cube root, just hit the math button and that'll bring up a menu and you can pick cube root. And then we call the number under the square root the radicand. So a radicand is the number under the root, and that's it. But we can also get mixed roots. So a mixed radical is when we have a number in front as well as a root. So what this means is we got a regular 2, and then we're going to be multiplying it by the square root of 3. Okay, so we don't need to write the multiplying sign, but that's what it means. So you might see it sometimes with a multiplying, you might also just see it with a dot. So 2 times the root of 3, but in either case, that's what it means. So it's a regular 2 number times just the square root of 3. And an entire radical is basically when we only have a square root. So something like the square root of 12. So the square root of 12 is just an entire radical. We don't have a mixed thing where we have a regular number and a radical, just the radical by itself. And what we're going to see is that these two things are actually the same. 2 root 3 is actually the same thing as root 12. So the question is, how do we convert from one form to the other? So let's first of all do mixed to entire. Those tend to be the easier ones, so let's start with that. Okay, so what we want to do, let's do that one we just had here, 2 root 3. So what we want to do is we want to ask ourselves, well, how can we change that? So basically what we want to do is we want to use a perfect root chart, and I've got it posted on the Moodle, and I gave you guys paper copies. But what you want to do is think of how can we change a regular number into a square root and vice versa. So if we go 2 times 2, that's 4. So 2 is the same thing as square root of 4. 3 times 3 would be 9. 4 times 4 is 16. 5 times 5 is 25. And we can keep on going down the list. I'll just do a couple more here. 7 would be 49. 8 would be 64. 9 is 81. And 10 would be 100. Okay, so there's sort of our start of our perfect root list. So what we want to do when we convert is we want to change the whole number to a square root number. So 2, we could change that to root 4, right? Because 2 is the same thing as square root of 4, times square root of 3. And when we multiply radicals like this, that's the exact same thing as 4 times 3 under 1 square root, which would then be 12. So you can see on the last page, I told you 2 root 3 is the same thing as root 12, and we just proved that they are the same, right? Because we went 2 times 2 is 4, 4 times 3 is the 12. So most people do really well with these kind of questions. Let's do one more. So what would 3 root 5 change to? So because it's a 3 this time, we look on our chart, and we'll go to the 3 section. So 3 would equal root 9. So change the 3 into root 9. And then 9 times 5 is 45. So 3 root 5 is the same thing as root 45. Let's do one more. What happens if we have a negative? Let's suppose we have negative. Actually, let's do a different number. Let's do negative 5 root 3. So if there's a negative, just ignore the negative. Just leave it down in front. So think of it as sort of like being negative 1 times 5. So 5 would be changed to 25. The 3 will stay the same. And then 25 times 3 is 75. So you can see with a square root, if we have a negative, we want to keep it outside the root all the way through. The reason for that is if we moved it inside, if we tried to write this one as square root of negative 75, it would be wrong because you can't do a square root of a negative number, right? If you try square rooting any negative number on your calculator, it gives you error. So you can't do a square root of a negative number, so that just means if you have a negative, just leave it out front, outside of the square root sign. Okay, so the tougher ones is when we go the other way around. We want to change from an entire radical to a mixed radical. So these questions are a little bit more difficult. So you want to do the square root chart again, but we're just going to be working backwards. Okay, actually before we move on, let's go back to the last page. Let's just look to see what would happen if we had a cube root. So if I gave you the cube root of a number, okay, so let's suppose we did, let's erase this here quick. So if we had 2 times the cube root of 4, works the same way, except instead of doing square roots, we use the cube root column. So 2 times 2 times 2 would be 8. 3 times 3 times 3 would be 27. 4 times 4 times 4 would be 64, and so on. So we just use the different column. So we would change 2 into cube root of 8 instead of square root of 4. And then we have cube root of 8 times cube root of 4. 8 times 4 is 32. And we're done. So you can see with square roots, you just basically use the square root column. With cube roots, use the cube root column, but the process is exactly the same. So we just choose a different set of numbers when we change the whole numbers. Okay, so let's go back to changing from entire to mixed. So these are the ones that are a little bit more difficult. So, but they're the same process, we're just going backwards. So let's suppose if I gave you the square root of 50, and we want to change that to a mixed radical. So what we have to do is, if you look on the previous page, when we did these ones, so when we had, let's kind of look at this example here and work backwards. So we started with 45, then we're going to have to break it into 9 times 5, and then the square root of 9 becomes a regular 3. So that's the process we want to do with this. We want to change the 50 into two numbers being multiplied together, and then that'll change to just a regular number out front times the square root. Okay, so to go backwards like this, like I said, it's a little bit harder. Most people have more trouble with this. So what you want to do is think of, okay, we have 50. What can we break the 50 into? So square root of 50, we could break it into 5 and 10, right? 5 times 10 is 50. Or we could do 25 and 2. We could write them the other way around. We could go 10 and 5, or we could go 2 and 25. We could go 50 and 1. We could go 4 doesn't work. I think that's it. I don't think there's any other factors. So let's kind of figure, well, which one should we use? We got all these different combinations. Which one's going to be the best? First off, 50 and 1 would be a bad choice because square root of 1 is 1. So we don't change anything. We just have 1 times root 50, which is right back to what we started with. So that isn't going to work. So the next question is, should we use 5 and 10 or should we use 25 and 2? If we look at 5 and 10, neither of them are on our perfect root chart. So that means we're not going to be able to simplify them. We have root 5, root 10. Those are both decimals. Those aren't going to work. So we're going to have to then use 25 and 2. So you can see root 25 is on our chart. So that means that's a good thing. So now the next question is, should we go 25 and 2 or should we go 2 and 25? The best thing is going to be to do the perfect root first. So we want to take the root 50. Let's kind of start over here. So we want to take the root 50. And we want to choose the biggest root number that's on our perfect root chart. So 50. So root 50, we want to pick the biggest square root on the list. So we have 4, 9, 16, 25, 36, and so on. So we want to pick the biggest one, which will be 25 in this case. So write that one first, and then our leftover would be 2. So 25 times 2 is 50. So now, off of our perfect root chart, square root of 25 is the same thing as a regular 5. So we'll have 5 root 2. And then we're done. So you can see with working backwards, the trick then really is just making sure you pick the right factors. So let's try another one. So if I gave you the square root of 27, okay, so you want to ask yourself what divides by 27. So you want to make sure that they're one of the numbers on our chart. So we want to use 4, 9, 16, 25, 6 would be root 36, and so on. So a good way of doing this is sort of asking yourself what will divide evenly. So 27, it can't be anything bigger than 27, so 36, 49, all of those numbers won't work, so it's got to be less than 27. So if you go 27 divided by 5 on your 25 on your calculator, you get a decimal, so that doesn't work. 27 divided by 16, that'll give you a decimal, that doesn't work. 27 divided by 9 equals 3. So that's good. We want it to be a whole number. So 9 times 3 is 27. 9 is our perfect root on our chart. We're going to start with that one, so then we'll change 9 into just a regular 3, and we're done. Okay, so let's try another one. So if I gave you square root of, let's do 98. So square root of 98, so if we look at our chart, we'll keep going here. We got 64, 9 would be 81, 10 would be 100. Okay, so the 98 can't be anything bigger than 100, so that's not going to work. 98 divided by 81, that's a decimal. 98 divided by 64 is a decimal. 98 divided by 49 will give us 2. So then we'd change it to 49 times 2, and then we'd have square root of 49 as a regular 7. So our final answer should be 7 root 2. Okay, so you get the idea with these. And the only thing that's going to change is, same thing if you have a negative. Let's do one example where we have a negative. So if I gave you the negative of square root of 48. Okay, this one you got to be careful. Some people will pick 4 and 12. But we want to always pick the biggest one. So if you go 48, go down the list. 48 divided by 36 doesn't work. Divided by 25 doesn't work. 16 will work. So we'll get 16 and 3. So you can see here the negative just stays out front all the way along. So 16 would change to a 4. So we get negative 4 root 3 for that one. Okay. And the same thing works if we get cube roots. So if I gave you cube root of 32, we just use our cube root list, so we'd have 8, 27, 64, 125, and so on. The numbers get big fast, so we're not going to get too high with these ones. So you can see 32, we can't divide it by 27. 32 divided by 8 works. So we'd have 8 and 4. And then the cube root of 8 is just a regular 2. So our final answer should be 2 times cube root of 4. So cube roots work the same way, just use a different set of numbers. That's the only thing that changes. And we're done.